So we are audible to you?
Yes, sir is back. Yes, ma'am. Please continue. Now, sir have unmuted himself.
Yeah, I think, yeah. Hello, sir. Sir, good morning, sir.
Very good morning.
Sir, can we start?
Which one?
So, a very good morning to all the participants. I welcome you all on the fourth day of the faculty development program on emerging trends in the geotechnical. Today, we are here with our eminent speaker, Dr. S. Mohan. It's a great pleasure to have you, sir, in this program. And we are looking forward for exploring a new learning on the topics data mining application in geo-environmental engineering. So, Dr. Mohan is working as an institute chair professor at Environmental and Water Resource Engineering at Department of Civil Engineering, IIT Madras, and also a former director at National Institute of Technical Teachers Training and Research at Chennai. Addition to that, Sir is also a former director at Central Institute of Classical Tamil, Chennai. His major research areas include the soil waste management technologies, environmental impact assessment, advanced water and wastewater treatments, environmental system modeling, city water planning and analysis, water resource management, groundwater assessment, and management and contaminant transport modeling. At IIT Madras, Sir works very closely with the industries, the central and the state governments to formulate the policies and strategies for the advancement of environmental and water resources engineering sector at the state as well as at the national level. Sir is widely acclaimed for his contribution to the field of environmental pollution control, water resource management, rainwater harvesting, optimization, and simulation algorithms, reservoir operations, environmental impact assessment, and water and wastewater treatment studies. And he has also received several awards like Fellow of Institution of Public Health Engineers, Shiksha Ratan Puraskar, Fellow of Indian Waterworks Association, and many more are in his career. Dr. Mohan is the member, convener, and chairperson of many academics as well as administrative committees and policy making apex bodies all over India and over the field. So we are very pleased to have you, such a renowned expert with us and having an opportunity to gain some knowledge from his findings and experience. We welcome you, sir.
Thank you. Shall I start now? Or?
Yes, sir.
Yeah, right. Okay. Very good morning to all of you. All of you are there?
Yes, sir. All the participants are here.
Okay. They are muted, maybe, right?
Yes, sir. Yes,
yeah,
sir.
right.
They are muted.
Okay. Very good morning. So I am going to talk about data mining, which is a new technique and its applications in geotechnical engineering. So what my idea is to give an idea about what is data mining. Okay, so as you may be knowing, many of the computer development in computer science, if you look at it, the first application will be done by civil engineers. So most of the algorithms or optimization, even linear programming, the first application is in civil engineering. So similarly, for many development, whatever it is taking place in data mining, so I think civil engineering is not an exception, and that is why I thought that this will be a good area for you to learn something. And those who are doing some research, I think this is one of the good tool and technique which may be useful for you to whatever the data that you are collecting from the field and so on, use this technique which is much more advantageous than the earlier techniques. So my idea is to tell you what is data mining and how it can be applied to some problems. So we will the agenda of this particular talk is what is data mining and how the data mining life cycle and data mining process and methods. And then we'll come with the two case studies. One is on leachate prediction from landfill, and another is pile capacity estimation. So based on these two case studies, you will appreciate the real advantages of the data mining side. Okay, so we'll go. Shall we go into the detail? So you can just see, in fact, all engineers and scientists are data scientists. This is a very nice statement, which I like it, because we always, without data, you can't do anything. So whether it is civil engineering or mechanical or even in science, chemistry, physics, all those things, we need some data. So unless we know how to analyze the data or how to get the information from the data, then it is we cannot call ourselves from engineers and scientists. So the more importantly that we should know how to analyze the data, okay, or how to go deep into it rather than very whatever it is highly visible. That's a very simple one. So anyone can do that. But if you want to really learn something from that, you have to go deep into the data. So that is what is called data mining. So try to mine it because it's not directly visible. So you may have to do something like as a geotechnical engineer, you know what is the meaning of mining. Mining is some resources which are below the ground, which may be around 200-meter deep, but we are trying to take it out and then make it for our use. The same thing is data mining. So you have a lot of data. So try to jump into it and then try to come out with something that is going to be useful. Okay. So you can just see somebody is just pulling out and then it is given up. So the normal person say, I guess I should not do that. Whereas a scientist will look at it, I wonder if this happens every time. Okay. So, or what may be the reason for this has come out of it. So that's the way that a scientist or engineer will think over on anything will be entirely different. So we always look for some data. Okay. So kindly remember that all engineers and scientists are nothing but data scientists. Okay. So data mining, anything that we wanted to start, we will always go with the definition. Okay. So the data mining in a nutshell is an interdisciplinary subfield of computer science. It's a computational process of discovering patterns. This is more important in this thing. So more importantly, we try to discover the patterns in a large data sets involving methods of intersection of we use artificial intelligence, machine learning, statistics, and also the database system. So this is that means data mining is something where we use all the latest techniques like artificial intelligence, machine learning, statistics, database system, and so on. So even other technologies like visualization, big data, high performance computing, cloud computing, and others. Okay. So that way, this data mining is a outcome of many of these technologies which have developed over the years. Okay. So data mining is also called knowledge discovery and data mining. Okay. So that means we try to get some knowledge which is or non-trivial. Okay. At the same time, it is not explicitly available. So it is implicitly it is there. So we have to get something, and also that knowledge should be useful for further development. Okay. So that is what it is there. So nowadays, it need not be always data between numbers. Even text is also a data. Web browsing is also a data. An image is also a data. So you can use the image and then try to get the thing. Nowadays, people are using quite a lot on these images, text, and web for especially to find out the uh, fraudulent exercise by some people. So patterns must be valid and new patterns should be novel and potentially useful and understandable. Okay, so the data mining is that. So try you give as much as data. So from there you try to get the patterns which are non-trivial, implicit, and useful knowledge from the data sources. The data source may be a simple data with the numbers or text or web or image. Okay. So in a very simple word, if you want to get a small ring, okay, diamond ring. So how you get from uh, the diamond is hiding on this particular rock. So we try to shape that particular rock, okay, and then finally we come out with the data mining. So data mining is also like this. So given that there is, if you look at this rock, we never imagined that diamond may be inside as such. So there are some process or some kind of a process to be done to look at the diamond is there. After diamond you are getting it, you make it as a useful ring or maybe a necklace or whatever it is. So that is what is called data mining. That means from something which is not directly visible, you try to get out of that and then try to utilize for beneficial use. That is data mining. Hope this is something which is attractive for you or which is something very novel nowadays. Okay. So let us just look at this knowledge discovery in database. So this is what is called KDD. Okay. So this KDD is a process by which the data mining, this is one. There are other data mining techniques, but many people concentrate on this knowledge discovery in database. So sometimes it is not knowledge derivation is one of the major issue, but you try to always look for mainly the pattern matching. So the pattern matching there, you don't try to get knowledge out of it. That's why knowledge discovery in database is a separate part of the data mining. There are many other data mining. Suppose nowadays, you have uh, uh, a biometric. So the biometric is we are not getting any knowledge, but that's also a data mining. So you have lot of people's thumb impression has been put on, and it will automatically select if you put your thumb and then on the biometric machine, the door will be open. So there are many ways that data mining can be done, but we are more concentrating on, or this particular lecture will concentrate on discovery of knowledge from the data. Okay, so that is what we may have to look at it. So this is KDD is a automatic extraction of non-obvious hidden knowledge from large volumes of data. Okay, so the data, sometime you get a large amount of data. We never see the whole data set, but we'll put that into the memory of computers, and then you apply the data mining algorithms. So try to get what may be useful for us. Then from that, you get what is called knowledge. And how the knowledge can be represented or useful, that also it is not purely computer. So you just run algorithm, get the results, and then you apply your mind to see that whether I can use it or not. So what is data? All of you might be aware, but let us just to see there are many data which are available. Even you yourself is a database. You have a lot of information, lot of data, and you have the thing. So it is, and data is just collection of fact. It may be number, it may be what your image that you might have seen, or maybe you might have seen a movie that it is there. All those things are is called data. So it can be a number, or suppose you say that this is the new car, okay, this is Pata, so or this is a database, like that, what it is there. So earlier it was a very small data, so we have there will be always structured, somebody writes it on the database and so on. So now the data now is large, huge, and also it is unstructured. And it is not that one person is collecting data. Now many people are collecting data as such. So each one will form his own way of coding the data. So that way, this data also is now one thing that you may have to have a good algorithm to make this huge unstructured data into huge structured data. So that is what is called, we'll see, that's what's called data warehousing. So that itself is a good research area by computer science, but we try to borrow that and then use it for getting more information from the data. Okay. So data comes from everywhere. It need not be always come from, so even from anything. So, and please remember, geotechnical engineers or civil engineers, we have a lot of database, and every project is a form of a database, and you have weather station, and you have anything that you name, that there is some database that it is coming from there. Okay. So there is, and and please remember, now wherever we go, we are data file. Okay. I think whether you understand it or not, even if you are going into a store and you are um, uh, you are just sweeping your card, so automatically your information has gone. So and so has purchased this brand of banian, or this brand of sari, or this brand of pant. All those things are going as such. So tomorrow they may call you and then say that you are interested in this particular type. We are giving you something. So every time nowadays, that what you are purchasing, what you are eating, and where you are going, and how many times that you are going, all of them are data filed. Okay. So don't always think that sweeping or swapping a card does not say anything. All your data has been there. And this data, and sometime now smartphones are tracking our locations. So especially these are all good thing for the, especially in the house, the wife can track where the husband is going, or the husband can track where his wife is in the store. So there are a lot of things. So we leave a data trail in our web browsing. Interaction in social networks are also recorded. Facebook tells about history of your activities. All you buy from supermarket, including the brand, frequency of visit, the amount spent, etc., all recorded. Okay. So privacy is an important issue. We talk about it, but this is not covered in this particular one. Okay. So uh, there are something that privacy aware data mining, like, at the beginning it was saying that your talk is recorded. So that means privacy is there, but it is made aware that data mining. So this is a nice, it is not a joke, but it's a reality. uh, he is asking where the heck is my data, and it's there up in the clouds. So now we are going more on the cloud. All the data are put on cloud. That means if the cloud is there, anybody can, anyone can take your data. So you can just type Mohan or any name, or Mehul. So we can understand what his activities. So nowadays it is not that, you never think that you are very secretive. It is not possible, because anyhow you have to go. So that means, please remember that we are data files. Okay. So even whatever you do, it is getting data file. So we are making so much of electronics, so automatically your data is no longer secret. So it will be available. So people can find out what you have been doing from morning to evening in the computer. Okay. So everything is, you can track, and where he is going, what he is talking, all those things. Okay. So there are data. So sometimes you put objects, so the ID number, and you can just say whether and taxable income, and whether he has cheated or not cheated, all those things that it will be. And if he is cheated, then you try to find out where there is a problem. Okay, whether there is a pattern of people who is doing that particular one. So that is what we try to understand. So this is for each person, and these are all attribute. So this is refund, martial status, taxable income, whether he has done a correct one or not, and so on. Okay, so we have recorded data, temporal data, which is time series and sequence, spatial and spatial temporal data. So we have spatial data mainly from remote sensing, whereas spatial and temporal, what you will be also measuring, and then together you can get. You can also have graph data, unstructured data, and semi-structured data, paper publication, XML format, and so on. So, and what are we doing with this huge amount of data? Okay, this is one of the big questions that many times that we have been asking. There are a lot of data, but unfortunately, sometimes people don't give the data. But without, if you don't give the data who can really use that data to get some useful information, the data is no longer has any value. Okay, so let us all do data mining for whatever the data that you have. Okay, so these are all recorded data, what you are buying. Okay, so the data matrix you can, and also sometime the same data will be available at a different place, and each one will have a different format. Okay, so that also need to be looked into. So this is a spatial data. So you can just see where these particular type of trees are there, and also like this bird, with respect to time, how it is changing. All those things also you can get. So that's a spatial data and movement data. So from home where you are going, and this can be easily tracked if your family members have a smartphone, or graph data. So you can also get connected with as many number of people as possible. There is no limitations as such. So this is a structured data where you have a separate column and do that, whereas unstructured is you just note down in a piece of paper. That is unstructured data. Okay, so sometimes you may get a structured data or unstructured data, so we may have to use both the things. Okay, so this we have seen. Again, I am putting it to understand that. And data mining case is there are data mining can be used to find fraudulent credit card transactions, can also be used for tagging a mail as spam or genuine. So you also get a lot of mails which were spam, that automatically it does with the data mining, and then it goes into the spam. There is always possible to do that. So let us just see the life cycle, or what it is, or how the data is coming thing. So you can, first thing is data acquisition, okay, or getting the data. So you will get from multiple sources and then store it and develop a structured data asset. That is what is called target data. So this says about data acquisition. So maybe you can get from PDF or from phone, or maybe your other computers, or somebody has a record or scanned one. All those things can be converted into a uniform. First, you can store and then make it as a target data. So that's what is called the first step, data acquisition. The second is data pre-processing. Okay, so pre-processing is some data which may be spurious, or this data may be, you can easily say that this data is not correct. So that is data manipulation, and also you make a visualization or time series analysis. Then you apply the machine learning algorithm. So you get the pattern and evaluate it, and from that you get the knowledge. Okay, so the algorithm is, there are classification algorithm, regression algorithm, clustering algorithm. You need not be a master on this. These are all nowadays softwares are available. So it's not one software. There are n number of softwares are available for data mining. So you can download. There are many are freely available. So you can use that and then get to put it into a good knowledge representation. Okay. So this is a data mining process. Data warehouse is where the data from different format are brought into a uniform structured format. That is what is called data warehousing operation. Then selection, pre-processing, data mining, interpretation, and knowledge. So pre-processed data and patterns that you will be getting it. So this knowledge discovery, okay, has a sequential step. Number one is understanding the concept or understanding the business, why what we are going to do. Then understand the data, then preparing the data. This is 3, this is 2, this is 1, and then you do the modeling or algorithm, and then evaluation of the result, which is 5, and then you apply that into the field. Okay. So whereas all these things, the base is data. So the data comes from warehousing. So please remember this: understanding the business, understanding the data, preparing the data, and modeling and evaluation and interpretation and deployment. So these are the data mining taxonomy. So how do we go about it? Okay. So learning paradigms, whatever it is on the data mining task, modeling techniques, measures, and heuristic search method in that, supervised learning, classification, Dyson trees, information gain, and greedy recursive partitioning algorithm. So there are many algorithm. This I have listed only something. There are even in there are classification. There are many classification techniques are available. So you may have to look at based on the data, study the data, and which classification may be suitable, or maybe you apply every classification and then find out which classification method is good and so on. So, and again, you have supervised learning and unsupervised learning. Unsupervised learning is you just give the data, whatever it comes out. But supervised learning is you have the data, but you find that there is one particular spurious value, create a problem, then you try to remove that data, then you look at on that, that's a supervised or semi-supervised or online or active learning with uh, different data streams and then try to come out. And there is also a reinforcement learning, which is game theory, control theory, simulation based optimization, OR, robotics, and so on. So the learning paradigm or the data mining has all these things. You might have heard about in thing in neural network or something: supervised, unsupervised, semi-supervised, and reinforcement learning, reinforced learning actually. Okay. So in fact, in USA, they have made a review, the Harvard Business Review, and they found that, of course, they use the word sexiest job, or more importantly, the attractive job in USA is mainly on data scientists. So the having rare qualities that are much in demand, data scientists are already there. So that means wherever there is an attractive job, really the data scientists. So they are difficult and expensive to hire, given the very competitive market for their services, difficult to retain them. There simply aren't a lot of people with their combination of scientific background, computational analytical skill, as a data scientist. So if you want to go to USA or try to get some very good job, data mining is one of the very good area that you should look at. Okay. So there are classical examples which were really very successful proven. The first is Walmart. So the Walmart, you might have heard about it. Even I think it has come in India also, in Delhi and important cities. I'm sure it may be also there in other um, Ahmedabad and so on. So then they really increase their sales and so on by using data mining. Okay, we'll see how they have done it. And also healthcare transactions. So mainly the databases are analyzed, and when the cancer has a thing, or what are the factors which lead to cancer, and like that there are many diseases which people may not be aware of it, but from the database they were able to do that. And also the oil inventory, the mobile has done all geological data over 100 terabytes that they have collected data. So similarly, as a geotechnical engineer, you have a lot of data. So these data can be used to get some, okay, if this is a way, the geological structure, there is a possibility for oil may be there. So this is what it is being done using the database. Okay, data is the most important tool to gain competitive edge by providing improved customized services. Okay, so this has a lot of um, data overload in science, engineering, marketing, finance, healthcare, and retail. So in fact, these 4 areas that it has been proved to be highly successful as a tool. Okay, so this is what we have seen already. So data warehouse, target data, transform data, data mining, and pattern and rules, and you get the knowledge. So this is a process which we have already seen. So this is a overall process. You have to set a goal, data selection, acquisition, integration, cleaning, data reduction, and projection. So this all is your mainly from here to here. It is data warehouse. Data warehousing. Okay, so and match the goals and what is the data, then exploratory data analysis or data mining, interpretation and testing, consolidation and use. Okay, so you can just see here, it's a very simple thing. Suppose analyze the purchases in a supermarket. Customer 1, pizza, beer, cheese, bread, chips, and 2 has entirely different thing, and you have some 6 customer. I'm just saying 6 customer. And what is the knowledge that you get from here? Most of the things. So one is, whenever he get pizza, he gets a beer also, and possibly chips also. Okay, so that means there is a pattern. What they have done it is, and if pizza and beer are in one purchase, it is likely that chips are also in that purchase. Or wherever
Hello. Sir, are you there? Hello, am I audible, sir?
yeah, now it is okay. In between there is some problem. Okay,
Okay,
so
okay,
this
now it
is
is.
how I can continue.
Sir, again you have to share your screen. It is not shared.
Oh, all right.
Yes, sir. Got it.
You're getting it? Okay.
Yes, sir. Yes.
Right. So this is a very important. This is a very simple example for even a school boy can understand. So and what is the output? Output is the Walmart has put down wherever there is a combination, they put it very nearby. Like, if somebody is getting bread, the jam automatically he may purchase, so let it be together. Whereas in if I go to our uh, shopping complex or shopping, so it may be something will be different. So in fact, you are supposed to keep near the pizza corner the beer bottle, so everyone will get it. So uh, so we may have to analyze like this the base data. What is this is not suppose unless I look at the data, this particular pattern may not be visible. So more importantly, it is more on getting the pattern, okay, what it is there, okay. So this is very much needed for geotechnical engineering because you do lot of interpretation, okay. Every geotechnical engineer has to do lot of interpretation based on soil data, based on geological data, and also the test results and so on. Use this data mining to get the pattern and then use it, okay. So there are challenges. We have three V's, we call it. Its a volume of data is very high, and the rate at which you get the data, that itself the velocity is high, and also the variety of data. It may be transaction, it may be temporal data or spatial data, or at different formats, all of them. So the data, the major three problems are volume, velocity, and variety. Okay. So these three data to be looked into it and then make it as a good data which we can use. So that is what is called data warehousing. So a platform for online analytical processing. So you have a OLAP thing, whereas collect transactional data from several databases and organize them in a fashion amenable to analysis. Suppose you collect the soil data from Delhi or maybe Bombay or maybe in Chennai. So each one may be having a different format, and OLAP will make everything on its own and make a good kind of a structured data that it will be available. So you need not do that, but there is a good software which is online analytical processing. So you can just put that in the online OLAP, then you will be able to get the thing. Also called data mart, a critical component that it will be helpful in decision making. So like, which factor contributes more for occurrence of a landslide, or which strategy is best for remediation of contaminated site. So based on which are successful, which are not successful on the historical data, we can come out with based on those database or data warehouse, I'll be able to answer these queries. Okay. So this data online analytical data processing. So it first is whatever the data, it will make in the order, make an inventory, and also it does data cleaning. And if it is some data, I'm just putting as a sales, so it can come to data warehouse OLAP. Okay. So you will get automatically this particular data, and if there is something which is very high value or very low value, it will be asking us what to do. And if you say that you neglect it, it will do that thing and then come back. Okay. So this is data cleaning, and this is what we have seen that the selection, pre-processing, transformation. If I want to transform the data from like logarithmic transformation or some features alone that you want to do, and you do the data mining. So this is what we are concentrating. So it is search for patterns of interest, data mining method selection, pattern selection, pattern evaluation, pattern interpretation, and pattern visualization. So again, you have the evaluation also, you have the data evaluation pattern based on some performance measure and statistical validation of the model, visualization and descriptive statistics. So it's uh, even though there are many steps are there, all of them are put down as a capsule in a software. So you need not do all these things. So you just give the data in the format what it is needed, and automatically you will be able to get something. But it is, you may have to have more iterations to get what the best value that you can get. Okay. So just 1 minute. So as soon as you collect the data and then do the data warehousing, then you take the data set and keep something for large set for training and some validation also. So this may be, sorry, this may be 70% and this may be 30%. So we keep the data for validation, whether the same data or the knowledge what you are getting, if I am putting into the data, whether I'll be able to predict the system well. So if I get a knowledge base from the training data, put the knowledge base in the validation data and whether you are getting the prediction very well. So that is what we may have to look at it. And sometimes it may be overfitting because somebody, some people are more interested in data mining, so they may try all the method. That should not be the case. So overfitting also should be avoided. So let us look at how these techniques are being utilized. Okay. There are two major purposes for which we use the data mining. One is predictive. That means you develop a model and then predict on future scenarios or at a new place, whatever the whether it's a problem solving or landslide or something, that you develop a model using the past, let us say landslide. Uh, Based on the past data, you develop this particular one to predict what will be the happening in this particular site. So that is what is called predictive. Then the second is descriptive. So it is what is really controlling a particular process. You wanted to understand why landslide is happening, okay, or what are all the factors that will lead to landslide. So those things are descriptive. Okay, so predictive models are also available. Descriptive models are also available. In predictive, you can use regression technique, classification, or neural network Bayesian tree, Bayesian method, or Bayesian tree support vector machine, or collaborative filtering. Okay, and sometimes you can also use clustering. Also can be used here. Whereas here in the descriptive, you come out with rules, with the maybe 15 rules or 500 rules, and that rules will tell about how the system has been operated or how the system is uh, working on that. So those things are descriptive model. So there may be some time an overlap between prediction and description. So here classification, regression, and dependency modeling, whereas segmentation and change in deviation reduction, these are all description. Okay. So these are all the data mining techniques in descriptive, clustering, association, sequential analysis. Predictive, again, you have classification and regression. In classification, you have Bayesian tree, rule induction, neural network, nearest neighborhood classification. So I may not be able to cover all these methods, but you can choose a method, or these are all already modeled inside. Okay. So now let us look at the primary task of data mining. Classification is mainly finding the description of several predefined classes and classify a data into one of them. What is the meaning of that? It is more whether let us say earthquake, whether it's a severe or moderate or scale, whether it's on a Richter scale or something, that predefined classes you can classify based on all the past data. And regression maps a data item to a real value, predicts variable, and discovering the most significant changes. So that is what is called deviation and change direction. And please remember, the data mining, there is also another philosophically thing. No data is useless. So that means if there is a, suppose I put this a data. So even this is a peak. Okay. Normally for time series analysis, we will remove this. But data mining concepts say that there is something which has led to that particular thing. What is the reason? What is a pattern which lead to this high value? That also should be studied. So in data mining, no data is considered to be useless, or all data are useful. It gives some knowledge to you. So don't make a statistical thing or more than 2 standard deviation. I remove that the data. We should data mining does not say about it. So unless you feel that it is a very clear that it is an error in measurement, otherwise no data is discarded, should be discarded. So as I have said, classification is based on the data. You try to classify into different part. Maybe this is one classification, this is another classification, this another classification. So regression and clustering and also association rules. Okay, so the rules are, the kids usually get the rules very quickly. Okay, so in time series data, we do clustering, classification, normal or whatever it is, and motive discovery if there is some problem on particular thing, especially this medicinal thing, and visualization, motive association, query by content, and so on. Okay, so there are very good clustering you can get, and also the motive discovery, why the people are leaving the main road and then going here and so on. So the container ships and frequency travel prediction, all those things can be done. Regression, you have input and output variable. Finally, you get y equal to fx. Okay, this can be linear or non-linear or polynomial. Okay, so any one of them can be, you can predict what will be happening. So classification is, given the data, you try to classify them into how many are high earthquake, how many are medium, low, and so on. There are many methods which are nearest neighborhood, descent trees, neural network, Bayesian classifier, ensemble, and support vector machine, which is a very important method. And also, like you get smoke and cancer, you can try to get which one is a classification that you can come out. Okay, so again, clustering, all of you know about it. So you try to cluster those data which are behaving in a same way. And hierarchical clustering, so first level, then you reduce the point, and then at different level, k equal to 2 and k equal to 3, like that, the k is level on which that the association rules. Okay, so we try to get from here milk, bread, egg, somebody purchasing bread, sugar, bread, cereal, milk, bread, sugar, milk, cereal, and you can just see milk, bread, 4 people have purchased, bread and cereal, 3 people, and milk, bread, cereal, 2 people are there. So rule is whenever they get milk, there is also bread, it is 66%. And also you can have different, it's like an if then condition as such. Okay, so we will, and Dyson trees are the relationship between input and output, and get a rule, and that means Dyson on if it is a sunny, and if it is a warm, yes, you can go for play. So whatever the Dyson, overcast and chilly, no, sunny and chilly, yes, and maybe overcast, chilly, no, and so on. So you can just get yes, yes or no, and so here you can just see if it is cloudy, some data on yes and some data on why, no. So you can see if this is 3 or if it is how many yes are there, cloudy, 1, 2, okay. So 2 yes out of, and no is uh, cloudy, 1, only 1, okay. So you can just try to calculate what may be the confidence level or what may be the percentage and so on. So this is what the same thing. So you also have the visualization. Yeah, finally the results are visualized, how far that it is falling on a particular decision and so on. So there are many ways that you can visualize. So, and summarization, describe the features of the selected group. Even you can, it will also use the natural language. What you want to express, that it will come. Usually is in a combination of with the deviation reduction and other methods. Okay. So now let us look at what are the software tools are available. Okay. There are free or open source tool. So you can just go to this website. There are www.KDN nuggets. Okay, knowledge discovery nugget software suits. So you get a lot of things. And commercial tools are also available. IBM, Microsoft, and Oracle also they have the data mining. But there is a very good tool which is called Veka. Okay, so I use this and this R. Okay, so this both are very good, but there are rapid miner which are available, and also the orange is another software, and LKey and SciPy and numerical PY, all of them are freely available softwares. Okay, so now let us look at any questions on the data mining.
Participants, if anyone want to ask a question regarding the data mining, the basics up till which the sir had covered, you can raise up your hand. We will give you the permission to have a talk. Sir, up till now, no questions we have received in the chat box also. So later on, we can take up if some questions we
Okay,
are having.
right. Okay, so having seen fundamentals about data mining, so with one lecture, you can't become a master. So you have to start working on it. Okay, so now let us look at the case study. I'm going to give 2 case studies.
Sorry to
One
interrupt,
is,
sir. One question is there. Can you tell more about the K-means clustering?
okay, so there are no, my request is you have to read it. You know, this the K-means clustering is for at different levels. Okay, so the K is 1 or 2 or 3, or sometime it goes at 5. So depends upon the. Let me just go to the previous slide. So this is a data. So what we do is arbitrarily choose K object as initial cluster center. Okay. So if it K equal to 2, okay. So you are going to make a cluster only 2 types of cluster. Okay. So this is what the two clusters what it has formed. But it left out some of these things which are this also is left out and this also is left out. So now we say that yes, assign each of the objects to most similar center if it is only two, and whatever if it is not possible to allot it, that data won't be there. Okay, but as we have said, the data is not every data is valuable. So you can update the cluster means, then you try to find out whether there is the two data which are not coming in the cluster, there is some level, and then try to look at on the whether this data can be update the cluster means. So you can just one level that you have made a cluster with a particular mean value. So now if I am increasing the mean or a certain level, so you can have another cluster which you may be getting it, or update the cluster means and then you will get a reassign and then you get this. So this will be repeated with the different k means. So k is one cluster. If you put one cluster, definitely this doesn't work. So normally we start with two cluster, and sometimes the data are so much distributed, sometimes it go up to 5 or 6, but more than 5 it is not useful, because you can't have for the same data you can't have many clustering. So again, please remember, the first cluster, two cluster is first level, that means that's a real data. Then you modify whatever is not getting it clustered with some modification to make that as a updating the cluster means, so that it will also fall in line with that particular one. So finally you will be getting is data. Okay, so that's a k means cluster. So I hope that I made it clear. So let us just is that okay? Anyhow, they will be uh, on mute. So the case study one is leachate prediction modeling with temporal data mining approach. So temporal data is, it is not spatial. Sometime you may collect lot of borehole data at different places. That is what is called spatial data. Whereas temporal data is for a particular site, we get for as a time series or at or data and so on. So that is what we have done. This is called temporal data, because this is a leachate which comes out of this landfill. Okay, so the number of landfill sites are increasing in association to urban expansion. The growth of the open landfill subjected to climatic conditions generate huge quantity of leachate, and the leachate had been termed as one of the most common contaminant, and thereby influencing the groundwater aquifer over the time period, or more groundwater quality is deteriorated because of this. So the treatment of leachate generated from a landfill had been one of the more explored research domain. So let us just look at here. So the leachate research people have, but please remember, this is very costly affair. Treating the leachate, because the leachate will have around BOD of 13,000, COD of 25,000, and so on. So if I want to treat it, I have to use a lot of other things. So the treatment is not very easy way, but however, we may have to find out when the leachate becomes more, or can I control that particular leachate generation, then we have to understand what may be the factor which may be governing the leachate generation. So that is what we are doing it here. Use of membrane process are more effective compared to all other treatment technologies. The annual volume generated leachate increased significantly right after the recirculation is started. Apart from COD, the other characteristics observed that urban waste contribute to even the presence of mercury. All these research influences are going to be more critical based on quantity of leachate that is going to be generated. So, and few studies also address the prediction of leachate quality. Okay, so we have taken some 4 landfill, landfill A, B, C, D. Landfill A, we have 55 data sets, 46 data sets, 108 on C, and 37 data sets. But here the correlation between the data set is also very low. So what we have done is rainfall, quantity of waste, and the content, and also this is moisture content, and also the organic content as such. Okay. Just I'll call you by. So that based on that, we try to first initially do that. That is what we have done here. And just 1 minute, I will come back for your.
Sure, sir.
Okay. So what we have done it is a simple method, or maybe more. So what we have done is whether the leachate generation is a linear process or it is a non-linear process as such. So we have used this multilinear regression prediction, mostly fit about mean and fail to capture the non-linearity. ANN, on the other hand, it is good where there is a non-linearity between the leachate generation and the parameters. So this ANN is very and the data mining exercise capable of recovery and build a model, even in case of poor correlation, utilizing the approach we have. Whenever, because normally if the correlation is poor, then multiple linear regression doesn't work. So that places we have used classification or clustering and association rules. We were able to get that particular thing very well in this particular result. Okay. So how to improve the efficiency of prediction? Whether there is any other approach that can extract knowledge from historical database. It is, we have a lot of data, but what to do with that? I think the database solution is one of the very good answer on that. So what we have done, the data mining model, we have the leachate landfill database. So we try to look at the temporal correlation, identification of sensitive input. Out of that, which is the input which is having more sensitive to the leachate generation. So using the chi-square evaluation technique, then we also, this is a preparation of data cleaning and grouping based on the range, and database split, mainly training, testing, and validation. So sometimes training is a data where it is used to develop the knowledge. Testing is for the same data, you remaining data we check up, whereas validation is you use predicts the model from one landfill and then use it for predicting on landfill B. Suppose I use the data for dissing from landfill A, whatever the results or the knowledge I get, I try to apply to the landfill C. Whether it is, if it works very well, that is what is called validation. Okay, so that's where we do that. So validation, testing, and training. So we use ANN, and there are many techniques which are available and evaluated simulated leachate quantity based on performance indicator. leachate prediction model with improved knowledge and future temporal leachate prediction in that area. Suppose I know what's the rainfall, I can easily find out what may be the leachate generation that it is available. So that's logic or the flow chart of the method what we have followed. And this is a green chart of the VECA. So how the classification rules. So you can just put whatever the items are very high, medium, low. And also you can just say that if the safety is high and buying is low and lock boot is big and process equals 0, then the classification is good. So like that, you can classify the training data or testing data. This VECA is very good software. Okay, so you can just download, and this is R statistics software. This is R statistics are more good for text mining. Okay, so this also will be because VECA sometimes it doesn't work very well for text mining, but here it is very good on that. So these regression models. So what we get from the screen list, then data mining on leachate prediction. So you can just see the best fit independent variable and rainfall, waste quantity, and the content, master content, LQ. What is leachate in T-1 and leachate quantity in T-2? Dependent variable is LQT. So that means LQT is a function of all these things. So we try to get a model. So what we have done with the neural network, okay, so this is the actual values. This is training phase. Okay, so you can see and the fitted model. Okay, using predicted model using the data mining. So almost it fit well, except maybe in some places that there is a gap. But when we have used for a testing phase, which those data have not been used for the this particular modeling. So you can just see, in fact, it is best fit than even the training phase. So the is 0.82 and mean square error is 2.8 and 2.2. So that way, this is one or one system. So this is for another system, landfill B, that's a landfill A, landfill B also, that this is training phase and testing phase. So landfill B, there is a lot of variation, so it is not predicting very well. Landfill C is predicting good, and landfill D is one of the problem. That's what we said, the poor correlation, but still this is the best model. Even if I am using a time series model, I may not be able to predict, but here it predicts very well, which may be of very useful. So what we have done for the landfill A, it's a classifier architecture with 6 input node and uh, 6 and 3 are intermediate layer and or hidden layer, and 1 is the output layer, and 650 iteration and learning rate is 0.24, and the classes are 4 classes onwards. So you can also make 8 classes or 10 classes. You can classify the data into that. So that worked very well. As you go more, the time it will take to model completely, it takes time. Okay, so these are the each one we have the but it is slightly poor performance. So ANN classifier, see, we have done a lot. So I'm not putting all of them the slide. So we have also checked up landfill A model, checking with landfill B and B model to see, and intercomparison also we have done. So which I have not told, but I think this is one thing that it come out is it's a very good easily modelable software or method. ANN classifier able to establish the relations between the variable irrespective of the database length and the correlation that. So that's one of the very important thing which we have studied here, whether you have 30 data or 58 data or 122 data, the database or the data mining is able to get the knowledge out of that. Okay, so that's very important. In comparison with the database relations, they inferred that the waste quantity dumped in 2 time steps ahead in the landfill contributes to leachate quantity of the current time period. That means whatever the major land leachate quantity comes from the 2 days back dumping. So that means it takes 2 days to get the generation as such. Even though the classifier is able to classify the future incident with NSC 0.8, that's a peak generation is mapped with reasonable certainty. On the other hand, the ANN classifier fails to capture a sudden fluctuation, especially sudden rise in reach quantity instant. So what we have done it is the sudden rise, if it is not picking out, we have taken only this peak data separately, and then we have modeled it. So whenever there is a peak rate, then it uses that model. So that works very well. So the second case study, what we have done is mainly prediction of file capacity. A database derived from geotechnical test results are normally noisy and contain multidimensional type of uncertainty. In order to cope with such complexity of geotechnical behavior and the spatial variability of the soil and rock materials, classical forms of engineering and design models are justifiably reduced to simplified mathematical expression. This case study deals with driven file capacity assessment from a large amount of data about the soil profile, SPT, okay, and file test. Knowing the soil profile and standard penetration test attributes, engineer can use data mining to models to make the predictions about the expected file capacity. So it is centered on experimenting with the algorithms provided by data mining tools, namely VECA 3.2. So what we have done, so these are the we have already seen. So you can just see these are the some of the data. If the perimeter is this much, length is there, then the capacity is. So we try to, for the same capacity, you can see that there are different variables combination that it works out, which we never come across. So that is what an association model is made up of series of item sets and the rule that describes how these items are grouped together. This is one group that it comes. That means where the capacity is from 600 to 610. Okay, so you can easily get very easily this particular thing. And data incepts interpretation. So we have taken steel piles H section, steel pile 5 section, and pre-stressed concrete piles. So we have the data. So we have taken the record from Liang, from this is from University of Kentucky, and 28 files from group 1, 27 from group 2, and 39 from group 3. So these are the driven files, what and the file capacity, what it has been estimated. So the VECA 2 was used, the number of steps, define a data source and source view, and these are all we have seen. So this is a training data. So what we have given training data into this, and it's a very simple. You can put in any format and make it as a comma separated value. It's very easily you can do that. So what we have done it is file capacity decision trees mining model, clustering model, naive based model, association rules, neural network mining model. So these are all the models which way. It takes a lot of time for you to do run the data, run the model. If it's not working well, modify the system and so on. It takes time. So we have used the cluster. Somebody was asking a question on. So mainly at different clusters. So we find that there are totally 9 clusters that it will be R around 10 clusters with maybe following. And these are the neural network data, the neural network mining models, and the association rules model that we were able to get. And so we get the measured file capacity and predicted. One is predicted. This side is predicted. I think this is not correct. This is predicted file capacity, and this is a method. So you can just see almost very good thing for H files and steel file and also PSC file. The best results of prediction obtained for neural network model and the associated rules model both have a good correlation of 0.9 and higher. The Dyson trees and naive-based model. So here again, so you can just see the neural network, Dyson tree, clustering, association, and actual method data. Okay, the clustering mining model performs very well. Okay, so for this particular one, with and indicates a correlation coefficient of 0.88. On the other hand, for the steel pipe files, the performance of neural network model shows a correlation coefficient of 0.93, whereas association rules mining model indicate 0.86. So sometimes it is not a pure correlation coefficient alone will decide about the prediction capability. So correlation only says if X is increasing, Y is also increasing. 80%, 86% of the time that it is increasing, but it never says about the magnitude. Sometimes the magnitude will be, whereas Dyson tree and naive Bayes model did not work, whereas the clustering discrimination algorithm works well for steel file. And for PSC files, association rules has a highest coefficient, and clustering model also is very good. So PSC files, almost all the models work very well. So I'll just quickly run through the Veka software side. So this is the first screen, what you will be seeing once you implement that. So you can just put Veka download, then automatically, or the University of Waikato. Okay. So this is what it comes. So you can put the data, whatever from the desktop itself, you can take that. In CSV is comma separated value. Okay, CSV data files, which is very simple. So you can put anything on that. So you can choose the method, and you can open the file. So there are many concepts. So there are, and these are all the data what we have given: file length, depth, wall thickness, area of file toe, and circumference, sapped soil type, toe soil type, length of flow gauge, penetration, blow count. So you can imagine that almost around 18 variable, and tested capacity is what it has been achieved. So you can just see, once you give the data, then it gives a minimum maximum for each one. So this is for file length. Similarly, if I click on that, I'll get all those statistics here, which is plotted here. Okay. And here there are, this is the normal thing. If you click on that, it comes Baker classifier, and you have base classification or functions. Again here, Gaussian process or linear regression and multi-layer perceptron. If you want to know what is multi-layer perceptron, if you click on it, it tells about all those things. Then there are many other, and with M5 rules and trees are also available. So almost around more than 56 methods that you can get from here. So this is what multi-layer perceptron. You can give this data. So you can click on it and get all these things. So, and you can choose the output using this. And this is what it is coming. So what is the actual, and what is the prediction, what is the error? 580 is actual, 570 is predicted, 600, 615, 629, 649. So it's a good thing. And also the for each one, what is the attribute, how it contributes, and the correlation coefficient is 0.9977. Mean absolute error, root mean square error, relative absolute error, all those things you will be getting. This is for another thing, another this for another one. So the conclusions from the case studies: soil properties vary widely at a given site or even at the different sites, and more on the performance of these models have been very encouraging. So you can start working on it if you could get a lot of data and make an application for different data, and then develop a database and then use it for data mining. So you will be able to do that. Once the series of data mining model defined and refined in a loop process, that you will be able to get a little more detail on that. So my concluding remarks are takeaways: understand the data mining first, use appropriate tool or technique that best suits the problem in hand, not the other way around. Because I have a tool, I should not be go on using it. Okay, start by solving simple problem first before moving to complex ones. Spend some time to explore, and just one minute. The correction portal. And data preparation is very important for building effective models. Data mining is an experimental iterative process. Try to tackle the problem with different analytical data analytic. That's what we are. It is clever to solve complex problems with simple techniques. Okay, so I think I'll stop here. If you have any questions, or there are.
Yes, sir. Thank you, sir. The session was very informative. We are having some questions. I will read it out for you. How to remove the noise data from the data set? How we can remove the noisy data from the data set?
No, first thing is in data mining, the noise removal is not necessary. Okay, because the data mining always say that every data has some knowledge. Okay, whether noise also there is some knowledge. See, earlier we have statistics model. So there it may not be able to handle the noise or the variability or the sudden spurious thing. Whereas data mining helps on that. Why suddenly there is a noise or something? So, but on the other hand, noise removal technique, there are many noise removal techniques are there, like you can make a square root transformation, or you can take a logarithmic transformation. There are many other techniques which will reduce the noise. But at the same time, in data mining, the basic principle is every data has some knowledge in it. Don't throw away the data, but put the data inside the data mining. So it will do that thing. Only thing is format should be the same. So that is what the warehouse will do. If you get data from different, suppose I get a data from Gujarat, data from Delhi, each one will have a different format. We don't have a standardization of the format on, let us say, file testing. So those data, when it comes into it, it will arrange it according to one format. That is what data OLAP. Okay. So remember the Ola taxi. So this is OLAP. Okay. So that it will be. So I would say that you need not be worried about removing the noise in data mining. Okay. Is that clear to you? Right.
Yes. Sir, one more question is that how the association rules are defined. I think in the case study regarding the pile capacity prediction, you have
Okay.
mentioned the association rules. So how they are
Yeah.
defined?
See, the association rules are, suppose you classify the data into different classes. Okay. So pile capacity is high, pile capacity is medium, pile capacity is normal or low and very low. You can classify that, and the data also you will be, suppose you have the let us take the example here. So you have the data, what we have seen. So here also you can have a different thing. You know the depth that also can be classified. Wall thickness can be classified. Whereas whether it is a toe soil type or soft soil type, this is one or two, whatever the number. Okay. So now what are the combination of the class which will result in the maximum capacity of pile, okay, or the pile capacity being 600 to 620 or 500 to 550. You can classify the capacity based on our standards and put that classification of the data. If you just give that class, automatically it will make a class into so every data wherever it is possible, it will be made a class. So here it is toe soil type either 0 or 1, yes or no, okay, or soft soil type 0 or 1, like that. Whereas penetration, blow count, these are all you can classify. It is only small blow count, which is large blow count, like that you can have the classification. So let us say 19 variables are there. These 19 variable, okay, and each one has a class. So 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. So what combination of these 19 variable will result in high capacity? Based on the data, it will tell about it. That is what is called how the different variables are associating itself to get what the system as such, what the expected thing. So you can just see the rules, maybe somewhere I have. I don't have, but I think we have maybe. Okay, so this may be something that you will be able to get. So file type, capacity, and this also what we have done, it is sometime 19 variable we are giving 1, but we have also made a smaller change. Instead of 19, I take only 555 separately and to predict that what it will be there. So we have done also principal component analysis to reduce this 19 to 5 variable, and that 5 variables are classified and the output also is classified. Try to make a correlation between that. So you will be finally getting a rule if perimeter is between this and if the depth is between this, and that will result in the capacity which may be of between 500 to 550. That means if I want to achieve 500 to 550 thing, what are the combinations that you may be needed? So those way that you can get the association rules. Is that clear? The rules may be multiple number. So these are all different combinations. So you can just see the file capacity of one particular value will be at different combination will result in. So these are all some 4 variable, and sometimes it is only depends on 1 or 2 variables. Okay, this is 2 variable, this is 4 variable, these are all only 1 variable that it is. So like that you may be we can't say that every variable will participate on every rule. So but we have different rules. The number of rules may be 300 or 400, or even for 5 rules maybe more than enough to explain the output or predicting the capacity. Is that okay? I
Yes,
hope
sir.
that I have explained it.
I think the rules are nothing but the conditions which we are putting up into our problems. It's just like the rules which are
Yeah,
given
right,
about
right.
the design in the games to achieve the
No,
aim?
the number of rules need not be
Can vary.
based on only the number of variables. It can be
Okay,
very high. Okay.
okay, okay. Sir, one more question is that what is the scope of data mining in seismic hazard analysis? I think at the initial slides you have given up some example based on this how to analyze the earthquake catalogs or the earthquake data. So can you just broadly explain that what will be the scope of this data mining in the seismic hazard analysis?
What is the source of data? That's what you're asking.
Scope of the data mining in these seismic hazard analysis.
No,
How we can
sorry,
apply, sir? I think the question is framed in this way that how data mining will be helpful in analyzing the seismic hazards.
seismic hazards. Okay.
Yes.
So you have a lot of data on the past data. So you try to find out what, let us say, this is scale is this much, and what are the situations, what it led to that particular data. So you know what is the dependent variable. What is the dependent variable is seismic hazard. Independent variables are many variables. So you are knowledgeable on that. So use that, whatever the data that it's available, and it need not be because some places they would not have collected all data, but they would have collected only some five set of data. Whereas in some places they have lot of instrumentation, they may get 20 data. But if you put all of them, it will give you a good conclusion as such. So you can get it mainly depends on what the data available, and give that, even if it is three sets of data or five sets of data or five variable only I have, I will be still be able to do something out of that particular one. So these data that you may have to get from the Ministry of Earth Sciences, or maybe wherever the data that it is available, there are some nowadays they share it through website. So
Yes.
you can,
Open sources,
you have
number
a
of
lot of
open
data on
sources
that.
are available with
Yeah,
us.
right. Okay, right. Okay, any other?
So participants, if anyone wants to interact, you can raise your hand. Uh, I think we are not having any more questions. So if
Okay.
participants, if you are having any questions, you can mail it to us. We will
Yeah.
try to,
You can send the
yes,
mail, then I will try to answer. Okay.
yeah, we can send your questions to the experts and your questions will be answered. So very thankful, sir. We are very thankful to you. So to give us such an informative session, and you have greatly explained that how meaningfully we can play with the data and can come up
Yeah.
with a novel solution to the problems.
Yeah.
As you have,
My only one request is the young
yes, sir.
people should take up this uh, area and then do good research on that.
Yes, sir.
Okay. So um, I would like to tell you a small story so that you
Sure.
remember at least the story. The story is there was a village, and during the summer season, beginning of summer season, there will always be festival on temples. I think all of you know that. So a village, the temple festival was going on. At that time, one small boy who is around 1 or 2 years has fallen into the tank. Every temple will have a tank nearby. So this tank, he has fallen inside. Immediately the other kids went to the mother, and the mother became very scary, and she was crying like anything to uh, save the child. Okay. But there are many people who went and saw that the child is struggling, but nobody jumped into it because it is very slushy, muddy, and all those things. So, but suddenly one person went inside, jumped into it, and brought the child up. And then everyone was, especially mother was thanking him, and other people are thanking him. But he suddenly got wild and he was shouting as, who has pushed me inside? Okay. So that means he was also not willing to get into it, but somebody has pushed it. So please remember that uh, some of you, I would like to push you in the slushy or messy tank. You should learn this data mining and do some good work and come with a good child. That is what my request to all of you. Do a good job. This is a new area where you yourself can do slog down, get the good results, and that gives a very good satisfaction of having done some good work. So I am only a catalyst. So please take this more forward. There are a lot of problems in geotechnical where we can apply data mining. So please do that. And I hope that if you get a good paper, let me see that if I am alive. Okay. Please do the needful asset. Thank you very much. Right.
Thank you so much,
So thank
sir.
you, Mehul and Saraswati, for giving the chance for giving and delivering a lecture to all your participants.
It's our
Thank you very
pleasure
much.
to have you,
So all the
sir. It's
best.
our
It's our
Yeah,
pleasure.
right.
pleasure, sir, and thank you for the wonderful
Yeah, right.
presentation. Thank you
Thank
so
you.
much.
Okay. Thank
Thank
you
you,
very
sir.
much. Right. Bye.
Okay. Have a great day, sir. Bye.
Yeah, right. You too.